In structural equation modeling, or SEM, model identification concerns whether model parameters can be solved in terms of elements of the population covariance matrix. An underidentified model arises when there are not enough pieces of information to solve for each parameter, meaning that at least one parameter cannot be expressed in terms of the covariance matrix. In such cases, parameters cannot be uniquely estimated, and SEM software typically produces a warning message. Although the degrees of freedom being negative is sufficient to indicate underidentification, it is not a necessary condition, meaning that models with degrees of freedom being equal to or greater than 0 may still be unidentified. In addition, because the parameters of an underidentified model are not estimable, the chi-squared test is unavailable, there are no testable assumptions, and the model must be respecified. A just identified model arises when there are just enough pieces of information to solve for each parameter, so each parameter can be solved in exactly one way in terms of elements of the population covariance matrix. These models necessarily have a degree of freedom of 0, although the degree of freedom being 0 alone does not guarantee just identification. For the just identified model, parameters can be estimated, but the model reproduces the observed covariance matrix perfectly, leading to a chi-squared value of 0. As a result, the overall model fit cannot be tested, and there are no testable assumptions. While such models are estimable, they are less ideal from a research perspective because they do not allow evaluation of model fit. An overidentified model arises when there are more than enough pieces of information to solve for the parameters, meaning at least one parameter can be solved in multiple ways in terms of elements of the population covariance matrix. These models require the degrees of freedom to be positive, although having positive degrees of freedom is not sufficient to ensure overidentification. Parameters can be estimated, and importantly, the model introduces one or more testable assumptions. The chi-squared test becomes available and evaluates whether the observed covariance matrix is consistent with the model-implied covariance matrix. For this reason, overidentified models are generally preferred, as they are both estimable and allow researchers to test the overall model fit.